Okay everyone, this video is going to be a little bit like a complement to my last video about how to do ratios. And I just know that there's probably going to be someone out there that's like, well, what's the maximum that I could probably get out of that transformer? So that is what we're going to do today. Okay, so right now, just like the last video, I've got my source coming in as 120 volts and I put it on my low side. So just to kind of show you, this is my meter with my probes again, right? So I'm gonna go right here. This is the input, so you know there's no witchcraft going on, right? I got 120 on both, and then over here should be 240, right? Because it's a step up 2 to 1. Same thing over here, and then the last one over here, okay? Which is 120. It's the same. It's a parallel coil with this one. So now we have 120, 120, 240, 240. Can we add them all together? Absolutely. We can add every single one of them together, and that would be the maximum voltage that we can get out of this. And that's going to be put like getting close to stretching the bounds and limits of this meter, okay? So 120 plus 120 is going to be 240, and so that's essentially 240, 240, 240, and that becomes 720. So we can get 720 volts out of this thing, and I will tell you, it's almost a little bit scary, but let's do it, right? That's just how you have to do things sometimes. So we're just going to put all the coils essentially in series with each other, okay? Just like the batteries on the back of your flashlight, that's what we're going to do. So this one right here is going to come over here, okay? And then we're going to take these and put these here. And now we should have 700 volts between this terminal and this one, okay? 720. And so I'm going to turn that little guy back on again, just so you know there's we're not messing around. 120 there still, 120 here, right? We're just doing the individual coils. 120 here, I'm sorry, 240 there, and then 240 here. Across the two 240s, should have 480, right? And then we're gonna add another 120 coil because that goes in series with it right here, right? So let's get over here. We're at 600, and then we're gonna get right here, and this is the last one, and there it is. And look, the meter changes. It doesn't do 720 point anymore. Now it does 720. Okay, so that's kind of unique, right? Like we're getting up there on that meter. See, you got a decimal point on this one, right? But when you go over here, still, the lead is the same as this lead, so we don't have a voltage change. But then you get here, and we get rid of that decimal point. So pretty neat. But just if you're kind of curious on how all this stuff works, that's I just wanted to give another showcase and identify that. You could go the opposite way. You could go in on the primary and step everything down. So that would be 60 volts on each one of these, right? So just understanding your ratios, different types of connections, whether or not you're in series or you're in parallel, or you're using your polarity to your advantage, or you're trying to take away. All of those make big differences, okay? And the last thing that I want to show off of this is that you can actually get, you could subtract 120 out of this coil if you really wanted to, okay? So how would we do that? Well, the difference between these two right here is that. So if I go right here and I put this, there's 120. There's 120 here, right? There's 240 here. But if this one is at 0, let's do this on the ground pins instead. Maybe that's a little bit easier for people to understand. If this one's at 0 and this one's at 0, we'll just call those all 0, right? Then this is 120 volts higher, and this one is 240 volts higher. So that means the difference between the two pins that I'm measuring is 120 to 240, so there's 240 volts between them. And that's how it works, okay? So it's all about the reference point. That's how these meters work. It has nothing to do with what it is to ground or what it is in anything else. It's the voltage between the two pins, between these two terminals. That's what we're looking at. So the reference is typically your black lead, and this is your polarity lead, your red one, right? So that means that anything, if you put it to DC and you switch them, then you'll get a negative, and that's why. So hopefully this helps. And like I said, it gets a little sketchy when you get up to 700 volts.